Do you still think that a time machine is a figment of the imagination of science fiction writers and futuristic movie makers? Creating a ship traveling at or near the speed of light is a realistic way to travel through time. Science can offer several options. Massive objects are believed to slow down time. This effect can be observed even on our planet, near the pyramids in Giza. But what if the object is trillions of times heavier than the colossal tomb of the pharaohs? This question was posed by the popularizer of science, scientist Stephen Hawking. A black hole is a perfect example of a significant slowdown in time. It is a massive, poorly understood, terrifying substance. What happens if a ship flying at 99% of light speed, about 1 billion kilometers per hour, approaches a monster weighing 4 million suns, a dark sphere with a diameter of 22 million kilometers? If the spacecraft flies too close, the wormhole will swallow it without pity. But by calculating the speed, trajectory, and following the edges of this structure, you can significantly compare to Earth-based observers. For a formation of this size, the safe distance would be 45 million kilometers. The ship's speed should be such that one revolution takes an average of 16 minutes. Then the pilots will not end up as scattered atoms. Inside the insatiable monster, under these conditions, time for astronauts will slow down by exactly half. This is the effect of the protective mechanism of the speed limit. This means that one flight around the black hole for people in the ship will take 8 minutes. When space travelers return to Earth after a 10-year journey, from the point of view of eyewitnesses far from the black hole, they will be 5 years younger than those who stayed waiting. The tired travelers will be met by a planet of the future. What a way to travel in time. Is it possible to achieve a similar effect on Earth? The answer is yes. It is possible on the territory of CERN in Geneva. In the tunnels of the research center, 9,300 powerful magnets accelerate proton beams to 99% of the speed of light. Still, time travel is most likely to be possible through the development of maximum speed limits in space. What should the ship of the future look like? Firstly, it should be truly gigantic. After all, it will carry a huge amount of fuel. It should be noted that its launch from the ground is not possible only from a planet-mounted launcher in orbit. Acceleration to the limits of light speed will take about 6 years. In 4 years, near the borders of the Alpha Centauri star system, the astronauts will begin a journey through the timescale. 2 Earth hours will be equated to 1 inside the ship. In 6 years, 60 minutes for travelers will be equal to an Earth year. These people will fly into a future beyond the reach of the rest of the world. What will the traveler see during the flight at light speed? And what dangers do modern scientists think they will face? Scientists believe, first, time distortion will go unnoticed by astronauts. For them, everything will be as it was before. We do not notice that at this moment we are rushing at a speed of 220 kilometers per second. That's how the solar system rushes around the center of the galaxy. But from the point of view of an outside observer, not only time will change inside the shuttle, the weight of everything inside will also triple. Now let's look through the window and forget the pictures you saw through the eyes of the Star Wars director aboard the Millennium Falcon. The astronaut will not see any tracing star trails. Physics students from the University of Leicester have disproved these speculations with a bang. The Doppler effect would have allowed Han Solo and his companions to see only a blindingly bright disk of background radiation. But this is nothing compared to what awaits the ship and the people on it. A shower of particles will fly through the ship's body like lightning. Think of an accident. The speed of cars in a head-on collision is summed up. The same mechanism works in space. In addition, astronauts are exposed to radiation of about 10,000 roentgens per second. The norm is 6 sieverts, which promises them instant death. Therefore, before launching manned expeditions, scientists will have to work hard to eliminate this incredible problem. These are distant prospects, but what is actually being done in this direction? In the recent past, the Breakthrough Starshot project was created. It was also developed by the famous scientist Stephen Hawking. A ship the size of a cookie bar is being designed. They are filled with equipment and reach speeds of up to 20% of light, which is 160 million kilometers per hour. The ship will rush to places where no human-made device has ever been. The ship will reach Alpha Centauri, 40 trillion kilometers away, in 20 years. If we use the speeds we are used to, the flight to the star system would take 30,000 years. Interestingly, a space shuttle, traveling at 160 million kilometers per hour, would reach Mars in 60 minutes. The mini-ship would be powered by a tiny radiation source of plutonium, 238, or americium, 241. Graphite will most likely be the material of the device. It is assumed that the images transmitted by the device will be as good as those obtained by a telescope with a radius of 300 kilometers in radius. A special ship will deliver 1,000 devices to the inter-orbit. Then, with the help of an ultra-thin reinforced solar sail and a laser pulse, they will be sent on a journey without a return ticket. It may take decades, but for now, humanity exists. There is definitely a possibility of a rocket catching up with the hands of the clock. So we can only wait and watch for new discoveries and achievements of scientists. I hope you enjoyed this video. If you want more interesting information about space and astronomy, be sure to subscribe to our channel. Don't forget to like this video so we know you appreciate our content. And leave us a comment with your thoughts and questions. Thank you for watching. Join us, and see you soon in the depths of space.